Alright, so smart homes. You've heard a lot about them. Are they really that smart? The answer is often no. So I have here this Arlec Grid Connect PC399HA for $22 from Bunnings. That's $22 Australian. So these things are pretty great, but Grid Connect, that's Arlec's home automation stuff, and every home automation, every smart home provider wants you to buy their own custom system. They may advertise that it's Alexa compatible or Google Home compatible or Apple Home compatible, but in the end you've got to use their software to configure them and to register them and onboard them and get them set up. That sucks, because in 5 or 10 years, Arlec are going to decide that Grid Connect's not worth their time. They're going to stop updating their mobile app. They're going to shut down the servers. They're going to sell the brand. They don't care about it anymore. And then all your stuff that you've invested is all worthless. So a solution to this is Tasmota, which was invented by a bunch of clever nerds, and it's a replacement firmware for these things to make them not Grid Connect anymore, to make them Tasmota. And it's open source, easy to set up, widely compatible. It's compatible with most smart home systems out there. It's really great. It's made to run on the ESP family of microcontrollers. So that includes the ESP8266, the ESP32, and whatever cheap ESP is inside this thing. I don't actually remember. I probably should look it up. But problem one, we've got to get this thing open in order to access the pins. We need to flash the firmware inside. So to do that, we've got to get out these weird little screws. Now you may see down inside the hole there, there's like 3 points in a triangle. I've made my own special tool that has 3 points on the end. You may have success making your own tool if you were to get a cheapo security bit set. I found the T27 is almost exactly right. And you just need to get a small file and file down every second tooth. So focus, there you go. So you see that they're both basically the same thing, just one's got twice as many teeth. So if you file off every second tooth, dress it up a little bit, you'll be right as rain. You can also just drill the screws out. That's what my dad did. Works alright, as long as you don't drill straight through. But let's crack this puppy open. So I've got a few of these now. Got one on the fan that's just over there. I'd move the camera if they weren't such a mess. And I've also got one on the clothes dryer, so I can turn the clothes dryer off if the price of electricity goes too high. So you can save on a bit of electricity, and then I'll turn it back on when the price of electricity drops down, usually in about 20 minutes or so. 20 minutes, come on. So take out those 2 weird screws, and let's get a closer look at those. So yeah, why do they do this, bastards? Open it up. Oh, bits gone everywhere. That's right. So here's the insides. We've got, there's the plug, there's the pins, and you can see the relays in there. Little Phillips here. Let's take that out. Pop them over there so they don't go walkabouts. There we go. So not much to it. 2 relays, turns off both active and neutral. Don't know why. So here's the ESP based chip here. It's a TYWE2S variant. You can see on the top there, there's an antenna on the PCB, and it interfaces to the rest of it with these pins on the bottom here. So usually there's lots of smarts and certification involved in making this little widget. The rest of it, less so. So they usually outsource all the difficult RF stuff to a module so they can just implement it and save the effort. So we're going to need to learn about these pins here, and there's also an IO0 pin on the back here that we're going to need to be interested in. So to flash the firmware onto these things, you're going to need one of these, which is a USB to Ttl Serial Converter. You can have these off eBay for $10. They're pretty ubiquitous. Easy to come by. You'll want one that can do 3 volts and 5 volts. Well, 3.3 volts and 5 volts, because this particular widget runs at 3.3 volts. You'll also need a soldering iron. So there's a couple of things we've got to do to get this ready to go. There is, unfortunately, your mileage may vary, but there is a capacitor here, this little brown rectangular thing here, right up against this button. That's got to go, and there's an LED there. So unfortunately, to save money, they use the programming pins to drive something. This capacitor there is to do something related to input or output. Maybe it's LED, maybe it's the input button, might be, given it's right there, might be one of the outputs for the relays, whatever. But the fact of the matter is that that capacitor stuffs up the programming in some cases. Some people have had success without removing it, just by hooking up this and away they go. But personally, I've had to remove it, and so has my dad. So it turns out that that particular component's not so important to the operation of the widget, so you can just go chomp it straight off. That's what my dad did. It works for him. I've unsoldered mine, and that works for me. Your mileage may vary, but I'm going to take it off to try out my new hot air reflow gun. I'm going to speed up time while I do that, because it takes a little while. So let's get this clamped up. And Bob's your uncle. So now, grab your soldering iron, which I'm sure you've got, and we've got to solder on some wires to get the data into our little chip. So we're going to need to hook up 5 wires. First of all, we'll do the power. So we've got to do 3.3 volts and ground. It's a bit fiddly getting into these little pins here. Actually, let me rearrange the camera a little bit. There we are. So getting into these pins is a bit of a ball ache. So we can do a little shortcut and solder to this pin up here, which we'll do as our ground, and then this pin here we'll do as our 5 volts. Sorry, 3.3 volts. So we'll grab a red wire for the second convention, solder up there, and we'll grab a black wire. Solder on there. Doesn't need to look pretty, it's not going to last very long. So now, here comes the old problem. So these things have got TX and RX, transmit and receive. Nobody knows what that means. What is that? Does that mean that you should hook it up to the transmit on this device, or is this the transmit from this converter? TXO, is that transmit out? RX in? Receive in? Huh? Maybe. Probably, that would make logical sense. I wouldn't count on it. So expect to have to flip around these pins. You can see that I've got these on a little header, so I can flip them around when I inevitably get it wrong. But I've got a photo I'm looking at over there, so I can get it right the first time. It will look very impressive. So I can solder this one onto here. Oh, where's my solder gone? It's a bit iffy. That'll do. Next one. They're a bit stingy with the solder from the factory, so I'll add a little bit more. Alright, donezo. So there's the 4. So I mentioned 5, didn't I? So there's an annoying one on the back. They didn't break out that pin for whatever reason. So let me flip this around a smidge. Clamp it back up. So you'll notice, where's my pointer eraser? Yeah. IO0 down there. So that brass pad, copper pad, we've got to solder to it. We have to solder to it. So get a bit of solder in there. Bit of blob on there. Come on, focus. There we are. Can't tell it to focus. Let's see how that goes. Then you get another bit of wire. And this is the trickiest part of all. Soldered on. Perfect. Now, if you've got a little crocodile clip, an alligator clip, which I did, here it is, you may find it, oh wait, that's attached to another piece of wire, dang it. Alright, plan B, cable tie. So that little pad there is easy to tear off, so you want to be careful. So what you may find advantageous, if you've got some sort of temporary means of sort of giving you a bit of strain relief to that red wire. So if you accidentally drop something and accidentally tug on the red wire, it doesn't rip that pad off and make things a lot easier. Make things a lot more difficult for yourself. Okay, so there's another complication which I've neglected to mention. So these things, you may remember that I mentioned before that you should get a version that can do 3.3 volts or 5 volts. My particular one is a bit gutless. It can't put out enough power on its VCC, on its 3.3 volt pin, to run one of these things. So I have to resort to using external power supply. I suspect this is just because my adapter is so old. It's 15 years old at this point. You probably get much better ones for cheap on eBay. So this is probably a step you're not going to have to worry about, but I'm going to hook up an external power supply here to my ground. Make sure it's not touching the 5 volts, 3.3 volts, god damn it. I'll turn that on. I'm going to hook up some electrons to it. Now I'm going to get my computer cable, which I've got here, honest. The other end's even connected to a computer. And then I'm going to plug it into here. I've got some blinky lights. Tickety boo. Okay, so this is the red one that goes around the back to the IO0 pin. So the trick is, it's got to be connected to ground when it turns on. So I'm going to disconnect the power, connect the power again, and now we're in programming mode. You may notice that the blue light did not turn on. So now we pop on over to Tasmota, which is over on my computer here. So I'm going to have to show you the mess of my workshop. So this is the Tasmota page for this hardware. So some clever clogs has gone through, some very patient person has gone through and done all the hard work and worked out which pins go to where for a lot of different hardware, like a lot of different hardware. If it's got an ESP chip in it, it's probably in this list. So thanks to them, thanks to you, whoever maintains Blackadder. So this is Tasmotizer. So this is the answer to doing computer stuff, doing nerd stuff being an absolute pain in the ass. So you plug in your USB to TTL converter, and it'll show up as a COM port. Mine's probably COM3, let's see how we go. So you can use release, which is the latest stable one that you should use, development if you're feeling fancy. I've already downloaded the release one, it's already there. I'm just selecting the bin file option so I don't have to download it again. And then progress bar, thinking about it, connecting, flashing, beepity boop, beep boop. Sorry for wobbling my hand around so much. apologies if you get motion sickness. So, what are you doing on the weekend? Cool. Me too. There, it's done. Right, it says power cycle the device. So go over here, clamp back down for a brief moment, power off, disconnect IO 0, power back on. And now it's running Tasmota. So there's one last step we have to do on this side of things. That's to send the config. So it used to be the case that there was a bunch of faff involved in writing the config into these things, but now it's much easier. So you can set up your Wi-Fi address here. If you want to write to an MQTT server, you can do that here. It's recommended. That's if you're running a local MQTT server as part of your like Home Assistant or any other home automation system. It's a pretty good idea to put that there. So this string of text you see here is just cut and paste directly from this page. So you just grab that string and it tells Tasmota what pins do what. So how to turn off the relays, how to blink the light, what to listen for the push button, all that sort of stuff. So fill in all these things. I'm going to type in my password here for my Wi-Fi and my MQTT just off camera. By which I mean I'm going to wheel over here and type it in. Then I click save, and it said the device will restart. We'll restart the device. I'll turn the power off, power back on, and we're all done. It's now running Tasmota, and once that light stops blinking, it will have connected to my Wi-Fi. Ta-da! So now we're away. We just got to unsolder all that stuff, and yeah, we have a fully functional Tasmota upgraded Arlec smart plug widget. So let's go through and undo all hard work. Bit of oxide. Where's my solder? One, two, three, four. Flip it over. Five. There we go. Now we wastefully chop off this cable tie here, and we're away. So if you're of a certain inclination, you could just leave it there, but I'm going to put that surface mount capacitor back on just because I have the equipment. So and Bob's your uncle. Should all be good. The button even works. It is really, really hot though. Ow. Okay, so now we do a quick little check that we haven't got any nasty blobs of solder doing anything naughty. Might trim these down a smidge. So something that's important to note is that this is not strictly something that the home gamer should be doing. This is something that an electrician should do, technically, maybe. This is not something that anyone should do if you want to preserve your warranty. That goes without saying. But you know, I'm an engineer, so that's close enough for cricket. Don't at me. Let's pull it back together. Ow, still a bit warm. Done. All right. Bye-bye.